This question is from GATE 2022 Mechanical Engineering paper, Set 1, question number 60. Consider a one-dimensional steady heat conduction process through a solid slab of thickness 0.1 meter. The higher temperature side A has a surface temperature of 80 degrees Celsius and the heat transfer rate per unit area to low temperature side B is 4.5 kilowatt per meter square. The thermal conductivity of the slab is 15 watt per meter Kelvin. The rate of entropy generation per unit area during the heat transfer process is dash watt per meter square Kelvin. Let's find out. We'll write the given things first. Higher temperature side, the temperature is given 80 degrees Celsius, which is nothing but T at inlet. Thermal conductivity K is given to be 15 watt per meter Kelvin. Heat transfer rate is given 4.5 kilowatt per meter square. So this is nothing but 4500 watt per meter square. Also thickness of the slab is given. We can take it as dx, which is 0.1 meter. Now first thing, we know that change in entropy in a control volume should be 0. So if we say that rate of entropy generation is S subscript GEN generated, then we can write S gen plus rate of entropy at the inlet minus rate of entropy at the exit. So this total sum will be equal to 0. That is, the entropy generated should be equal to the difference between the entropy at inlet and exit. Now, therefore, we can rearrange this and write down rate of entropy generated S gen will be equal to S at exit minus S at inlet. This can be written as heat transfer rate upon temperature at exit, because that is nothing but the rate of change of entropy, minus heat transfer rate upon temperature at inlet. Heat transfer rate Q is same at both inlet and exit. So we know the value of T at inlet, which is 80 degree. We know Q, but we need to find out T exit, and after finding out T exit, we'll be able to find the rate of entropy generated within the control volume. So let's do that. To find out T exit, we will use Fourier's law for heat transfer rate. So by Fourier's law, we have the heat transfer rate Q will be equal to thermal conductivity K into cross-sectional area A into rate of change of temperature with respect to the length. So here the change is taking place in the thickness direction. So we have taken dx as the thickness here. Substitute Q here. So we have 4500 is equal to value of K is given 15 into area, we can take unit value. So A we take as 1 meter square into dt can be written as the difference between temperatures at inlet and exit. So T inlet minus T exit, and dx is already given to us, which is 0.1 meter. Substituting the value of T inlet as 80 degrees Celsius, we will have T exit will be equal to 80 minus 4500 upon 15 by 0.1, which we can write it as 150. So this gives us the temperature at exit is 50 degrees Celsius. Now here when we substitute the value of temperatures, we should substitute it in terms of Kelvin. Because here we were calculating the difference between T inlet and T exit, taking temperature in terms of degrees Celsius or Kelvin would mean the same. Because delta T, when we consider in degrees Celsius and in Kelvin, the values will be equal to each other when we consider the difference between two temperatures. But when we are considering only the temperature here, it would make a difference if we substitute it in terms of degrees Celsius instead of Kelvin. So when we substitute it here, it should be Kelvin. And therefore, to find out generated rate of entropy, we substitute Q as 4500 itself, but we substitute temperature at exit as 50 plus 273, which is in terms of Kelvin, minus again 4500 divided by 80 plus 273. Also, substitute T exit and T inlet at the correct positions. So we have S generated as 1.184 watt per meter square Kelvin. Let's go back and fill in this answer. So the answer that we get is rate of entropy generation per unit area during the heat transfer process is 1.184 watt per meter square Kelvin. If you want to round it off to 2 decimal place, you can write the answer as 1.18 itself. And we can see that we are being asked it per unit area, and therefore we took the value of area as 1 meter square. To learn more about entropy, you can refer to the NPTEL video lecture 41, Entropy balance for reversible and irreversible processes. It's from the course Concepts of Thermodynamics. The course is taught by Professor Suman Chakrabarty. He is from IIT Kharagpur. I hope this solution helps you clear your doubt. Thank you.